Welcome students to the ACT practice test part 3. Today we will be looking, or in this video we will be looking at, hold on one second, my MemoPad is not working. I guess it helps if you turn it on. There we go. Today we'll be looking at numbers 21 through 30 on this video. As I've said on the other two videos, any spelling mistakes, please understand I do know how to spell. It is a type of mistake, and MemoPad does not have a spell check as far as I know anyways. And so because of that, we'll just ignore any of those and keep moving on, okay? My throat's a little raspy, so please excuse that. And let's go ahead and get started, okay? Let's take a look at number 21. Which of the following transformation, there should be a comma right there, by the way. Which of the following transformations shifts all points graphed in the standard XY coordinate plane down 5 coordinate units? Now, let's pause and talk about some things. First of all, we understand in a coordinate plane, this is the y-axis and this is the x-axis. So, if I have an ordered pair right here, that's 2, 1, and I want to move that up 3 places, I'm going to add 3 to my y, and so it becomes 2, 4. That makes sense. I mean, think about it. If I'm here at 2, 1, and I want to go up 3 units, then I add 1 to my y, or I add 3 to my y. Why do I add it to y? Because the vertical axis is y. Let's say I have this original point right here, 2, 1, and let's say I wanted to shift it 5 units to the left. Then I would take this 2 right here and I would subtract 5 because I'm going to the left, and that would end up putting me over here somewhere, -3, 1. So in other words, here's what I'm trying to express to you, and here's what they're teaching you on this problem. Here's what they're testing you on, excuse me. X values are left and right movement. Y values are vertical up and down movements. Okay, so with that in mind, let's go ahead and solve this problem now. If we can, if I can get rid of all these very quickly here. Which of the following transformations would shift everything down 5 coordinate units? Okay, down, so we know we're dealing with what letter? Y. Down would be negative, so -5. So as I look here, it's going to be letter A right here. It's saying if I take my standard point, XY, and I subtract 5 from the Y value, that means, and notice we didn't do anything to the X, so it did not move to the left or the right. If I subtract 5 from the Y value, that means I went down 5 coordinate units. Okay, so they're testing you here on your ability to visualize the coordinate plane and know what the X and Y values do and which axis is the Y and which axis is the X. Number 2. Let's see. I don't think I remembered to put that segment in here, so I'm gonna kind of just make it up here. That's my fault. Sorry about that. So there's line AC. This will be interesting, won't it? See if I can make this up on the fly here real quick. All right, now let's see. B is on AC. The length AB is 12 and BC is 20. Okay, we're going to put A right here and B right here and C way down here. Okay, sorry about that, guys. Let's go ahead and look at it. For line AC, B is on AC, which simply means they're all in a straight line. And the length of AB is 12. So I'm going to go ahead and put a 12 right here between AB. And the length of BC is 20. So I'm going to go ahead and put a length of 20 right here on BC. What is the distance in centimeters between C and the midpoint of AB? Now let's think about this. If they would have asked us what is the distance from C to A, that would be easy. From C to B we have 20. From B to A we have 12. So we add them together and we get 32. That's pretty simple. But that's not what they asked. They asked what is the distance from C to the midpoint of AB. Now let's talk about midpoint for a second, okay? Remember, me get this erased real quick here. Remember, midpoint means it is a point that falls right in the middle, thus it's called midpoint. So if I had a point right here and that was the midpoint, remember 12 was the length from here to here all the way across, okay? So if I put a midpoint right here, that point's in the middle of A and B, it says the midpoint of AB, then that means this little segment here would be what? 6, and this little segment here would be what? 6. So they want us to find the distance from C to the midpoint of AB, which is this point right here. That's the midpoint of AB. So the answer would be 26, right? From C to B, it's 20. And then from B to this point right here is 6 more, so 26. So the answer is J. So what are they testing you on here? The ability to read geometrical symbols, to know what midpoint means, to know what the length means, and how to use segment addition and or segment subtraction. Okay. Number 23. Which of the following expressions is a factored form of this trinomial? Now, very quickly, I want to point out to you this should be a very easy factor for you. Anytime you have a quadratic trinomial, quadratic means your highest power is 2. Trinomial means you have 3 terms, 1, 2, 3. And the lead coefficient is a 1. That means your front number here is a 1. Anytime that happens, the factorization is really easy. You just simply say to yourself, what two numbers, when multiplied together, give me this number right here, but when combined, give me this number here? Well, to me, it just pops right in my head. You might have to think about it a little bit, but I have a question for you. And if you don't know the answer, use your calculator. What's negative 3 times negative 2? Positive 6. And what if you added these, combined them? What's negative 3 plus negative 2? Negative 5. So these two numbers here satisfy what I just said. I said to you guys, we want to know two numbers that when multiplied together give you this, and when added together or combined give you this. And there's our two numbers right here. So the factorization would very simply be x minus 3, x minus 2. So the answer is A. Now, let me show you something else. For some of you that are watching this and you're like, Mr. Eric, you have no idea how bad I'm at factoring. I redefine horrible at factoring. Okay? I don't like this idea, and I think it's going to take a little too long, especially if their answer is down here at E. But what you could do if you're really bad at factoring and you just don't get it, take each group. Like the first group here is x minus 3, x minus 2. And multiply it out and see if you get this. Take your x times your x times your negative 2. And then take your negative 3 times x and negative 3 times negative 2. So x times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. Negative 3 times negative 2 is positive 6. Combine your two middle terms, x squared minus 5x plus 6. Look at that. You get this, which is this right here, so you know that's your answer. The only problem with that method is you were a little lucky on this problem. Remember, this is an actual ACT test that a student took about 6 months ago. But what if this answer here had been down here toward the bottom? Then you would have had to work through all of those until you finally got to your answer. So you really should practice your factoring and know how to do that. But they're testing your ability here to know how to factor a trinomial, a quadratic trinomial with a lead coefficient of 1, or how to take these and multiply them through and get this right here. All right, number 24. Now this is interesting. The sum of this and something is this. Now, let's just quickly rephrase this. What if I said to you, just watch this, the sum of 5 and something else is, I don't know, 8. Well, you should know right away the answer is 3, because 5 plus 3 is 8. Correct? Doesn't that make sense? But I've got another point I'd like to make very quickly. Let's say the numbers were really huge. Let's say I said the sum of 2,962 and some number is 6,391. That's going to be really hard to do in your head. So you know what you do? You take this number right here, 6,391, and you subtract the first number, 2,962, 8293, I think that's right. Anyways, if not, you get the idea, and I could put that number right here, and then I could say very easily the sum of, sum means add, by the way, in case you've forgotten that, the sum of 2962 and 3429 is 6391. So do you see how we did that with numbers? Well, it doesn't change because we're dealing with algebra expressions. We have the sum of this and something else is this. So I'm going to use this property or this principle up here. Notice how I took this first number and I subtracted the second one. So I'm going to take this expression here, 5x squared plus 3, and I'm going to subtract negative 2x squared plus 2x plus 8. The exact same thing, guys. I'm doing the exact same thing down here. Now, you should have learned in Algebra 1. Let me get a quick drink here. Hold on one second, please. You should have learned in Algebra 1, Algebra 2, even pre-algebra, that whenever you're adding or subtracting two polynomials, you look at the sign on the outside. If it's positive, you don't change anything on the inside, just bring it down. And then you should have learned if there's a negative sign out here, you go through and change all the signs. So you drop this sign, it's gone, and you change all the signs. So a negative 2x squared becomes a positive 2x squared. A positive 2x becomes a negative 2x. And a positive 8 becomes a negative 8. And now we combine like terms. 5x squared and 2x squared is 7x squared. Then bring down your x term, negative 2x, and then you have two like terms right here, a positive 3 and a negative 8. And of course those are constant terms. 3 minus 8 is negative 5. So there's our answer. Let's see if that matches anything. Letter H. Now, what you basically did was this. What you're basically saying is this. You're saying the sum of this and this, the sum of negative 2x squared plus 2x plus 8 and 7x squared minus 2x minus 5 equals this right here. So when you add these two, you'll get this, and that is true. So again, I hope that makes sense. If I had 8 plus a number equals 15, I could take this last number here, 15, subtract the first number, and get 7, and that's what goes right here. 8 plus 7 is 15. I hope that helps. Number 25. What are they testing back here? They're testing your ability to combine like terms to understand how to add and subtract polynomials. Okay? Very, very important that you know how to do that. Number 25. Now, if you're allowed to use a calculator on the ACT, and you are, and it saves you time, which it does, then please learn to use it. Okay? Now, here's what I want you to do. I want you, first of all, to learn how to use your fraction button on your on your calculator. So, this expression right here is equal to this. And the first thing you do is, I'm going to add these two up top. So, with your calculator, hit 3, then hit plus, then hit 1, then hit divided by, and then 9. It'll look just like that. So 3 plus 1 divided by 9, and hit enter. And you're going to get this on your screen, 3.111111111, okay? Now, I want you to do something else. So you're ready? Now hit, see the math button here? I want you to go ahead right now. Don't mess with your screen. Everything is exactly where you want it. Hit math, and then enter, enter. Push enter twice down here. And up on your screen should pop 28 over 9. So what you just learned how to do is how to add fractions and whole numbers and get out a fraction on your grapher. I call these calculators graphers, okay? So now put 28 over 9 right here for the top of your fraction, because 3 plus 1/9 is 28 over 9. Now go ahead and try this one on your own and see how you do. I'll kind of fill it in up here while you're doing it. Go ahead and type in 1 plus 1/18 and then hit math, enter, enter. And when you hit 1 plus 1 divided by 1/18. The decimal you should get out should be 1.055555556. And when you hit math, enter, you're going to get 19 over 18. Now again, I'm teaching you how to do this. If you know how to do this ahead of time, you can just whip through this. I mean, this problem could literally be done in 30 seconds or less. Okay, so you get 19 over 18. So 1 plus 1/18 is 19 over 18. So here's what you basically have. Are you ready? You have, don't forget that fraction means divide. So you have this whole fraction here divided by this whole fraction here. Now be very careful. I want you to use your calculator, but watch how you type it in. It's very important you do it this way. You do not want to type in 28 divided by 9 divided by 19 divided by 18. That will not work. I can guarantee you one thing, you'll get the wrong answer. Okay, you must tell your calculator, your grapher, you have to talk to it. Okay, you got to tell it that this whole fraction here is grouped together. So see these parenthesis buttons right here? You hit parentheses and then 28 divided by 9, and that should pop up, and then close your parentheses. Okay, then hit divide for this really big line right here. So hit divide, and then you're going to type in 19 divided by 18. And again, you want to tell your calculator, your grapher, that's one whole fraction. So use parentheses, 19 divided by 18, close your parentheses. Now, I've got to do that in mine real quick. I want to see what decimal I get out, so bear with me for 1 second, please. Okay, you should get out, I believe, what I'm getting out is 2, if you hit enter on this, if you've done it correctly, you should get out 2.947368421. Now hit math, enter, like you're supposed to. By the way, Mr. Hart, why can't I just leave it a decimal? Hey, you could if your answers over here were decimals, but look, they're not. Your answers aren't decimals. So that's why we got to change it to a fraction. If you hit math, enter, your screen should say 56 over 19. Now, unfortunately, none of these match 56 over 19. Okay? This is an improper fraction. So real quick, if you think about it, how many times does 19 go into 56? It goes in 2 times. And 19 times 2 is 38, so you have a remainder of 18 over 19. Now you really should know how to do that from middle school. Okay, I'm not being mean when I say that, but I mean, this is old stuff. When you have an improper fraction like 7 over 3, you know that 3 goes into 7 2 times with a remainder of 1, and your denominator is 3, so you leave it at 3. Same thing here, 56 over 19. You know that 19 goes into 56 2 times. 2 times 19 is 28, so that means you have a remainder of 18, and your denominator stays the same. So the answer would be 2 and 18, 19. So they're testing your ability to combine, to simplify or solve a complex fraction. The complex fraction is when you have fractions within a fraction. Excuse me for a second, please. And they're just making sure you know how to combine that and then divide it out in the end. Okay? All right, number 26. Ava starts with a long list of numbers, each of which she is going to multiply by 4/3 and then divide by 1/6. Sounds like a lot of work. She could get the same results by just simply multiplying each number on her list by just one number. And which of these numbers would it be? Well, I want to show you something down here to make you think a little bit. You know, forbid that we do that. If I had 5, just kind of watch, okay? And I first multiplied it by, I don't know, 8, and then divided it by 4, what would I get? Let's see. 5 times 8 is 40. 40 divided by 4 is 10. Easy enough. Now, you know that when you have multiplying, like 5 times 6 times 3, you know you can go in any order. You can take 5 times 6 times 3, or 3 times 6 times 5, or 5 times 3 times 6, or 6 times 5 times 3, or whatever. You know that, okay? But how about when we have a division thrown here? Did you know you could do the same thing? Did you know you can go in any order you want to? You could say 5 times 2. You could first do your division if you want to. Okay, so 8 divided by 4 is 2, and then 5 times 2 is 10. So you might not have known that, or maybe you did, but whenever you have multiplication and division and nothing left, nothing else except that, you can do them in whatever order that you want to. Okay, you really can, it doesn't matter. So now we're going to apply that property up here. Ava has a long list of numbers. We'll call her first number A. Okay, now what is she going to do with a? Well, it says right here she's going to multiply it by what? 4/3, and then she's going to divide it by what? 1/6. Correct? Sure, I'm correct. Yes, definitely. That sounded arrogant. Sorry. I mean, yes, that's correct. Okay. So I've taken her first number, I've multiplied it by 4/3, and I'm dividing it by 1/6. Okay. Now, what I just showed you down here when I had 5 times 8 divided by 4, I showed you could do your division first, didn't I? So let's bring down our a and let's quickly divide these. Okay. Let's go back to our, well, I'm going to go ahead and, well, we should use our graphing calculator. So with your graphing calculator, we're going to divide these two fractions. So put parentheses, 4 divided by 3, close your parentheses, then hit divide. I'm going to go back a page. It should look like this. So you're going to have 4/3. You're going to have 4/3 in parentheses, and then hit divided by, so a division symbol, and then 4/3 divided by 1 divided by 6, close your parentheses. Okay, it should look like that. And if you do that correctly, you're actually going to get out a whole number. So it just pops out. If you enter, it comes out 8. So what you see here is when you take 4/3 divided by 1/6, you get what? 8. So instead of taking each number in her list and multiplying it by what? 4/3, and then dividing it by what? 1/6. It'd be easier to take each number and just multiply it by 8, which is the same thing because 4/3 divided by 1/6, this whole expression here just equals 8. So really you're just multiplying each number by 8. So the answer is K. All that you're doing is multiplying each number by 8. Okay? So what are they testing you? Well, they're testing your ability to understand multiplication and division and how you can go in any order you want to. And they're just testing your problem solving ability to reason through a situation. Number 27. Okay, now this would be pretty simple here, guys. I'm just going to skip right to the end. What is the y-intercept? Now look, if you don't know this, you need to learn this right now, okay? When you're looking for the x-intercept, you put 0. I know I'm just trying to write faster, guys. Sorry if I'm sloppy. I'm just trying to go fast, okay? When you're trying to find an x-intercept, you put 0 in for y, and when you're trying to find a y-intercept, you put 0 in for x. So look at what we're doing here. We're trying to find the y-intercept, which means we're going to put a 0 in for x. So 6x equals 2y minus 18. Where the x is, I'm going to go ahead and substitute a 0. So I'm left with 2y minus 18. And then 6 times 0. Remember where the x is, I put a 0. 6 times 0 is 0. So 0 equals 2y minus 18. Now we're going to solve for y. Bring the 18 over. When you bring it over, it becomes a positive 18. So I'm going to cross this off and put it over here. Positive 18. 0 plus 18 is 18. 18 equals 2y. Divide both sides by 9, or divide both sides by 2, excuse me, and y equals 9. So, what is the y-intercept? 9, letter E, 9. Okay, moving on to number 28. Now, this will be a little challenging. Let me grab another quick drink here. Okay, given function f of x equals x minus 5, and g of x, that's how you say that, by the way, it's like of, it's f of x, and g of x equals 5 minus x squared. What is f of g of 4? That's how you say that. F of g of 4. Okay? That's how you say that. Well, this is going to be a tough one, and some of you will get it, some of you won't. No slam intended. I'm just saying that some of you have done really well in your algebras and your pre-cal and your advanced math, and some of you haven't. So that's fine, but let me show you how to do this, and hopefully most of you, if not all of you, hopefully most of you will get this. Now, what we have here is they want us to find f of g of 4. Now, what that means, first of all, is start on the inside. They want us to find g of 4, okay? So, I have f of g of negative 4. Now what that means, forget the f just for a second, what that means is I want to find g of 4, or g of negative 4, excuse me. Now what that simply means is you take your g function, which is right here, and you substitute negative 4 in for x, okay? So here's my g function. Are you ready? G of x equals 5 minus x squared. So g of x equals 5 minus, and then parentheses, negative 4, and then notice the squared on the outside, okay? So where x is, I put negative 4. Why negative 4? Because it says g of negative 4. What that means is I want to evaluate the function g at 4, at negative 4. Now, when you square a negative 4, guys, look, it's in parentheses. It's negative 4 times negative 4. So now you have 5, and then bring down your negative sign, and then negative 4 times negative 4 squared is a positive 16. So if you want to put a positive, let me go ahead and back this up here. If you feel comfortable putting this, 5 minus a positive 16, that's fine, I don't mind that. It's a little redundant, but that's okay. So I brought down my 5, I brought down my negative sign right here, and then I squared my negative 4. Negative 4 times negative 4 is 16. Now 5 minus a positive 16, if you struggle with your signs, then use your grapher. Just type it in just like this. 5 minus a positive 16 is 5 minus 16. You will get negative 11. So I have a question for you. Did I evaluate g of f of negative 4? Yes, I did. I put negative 4 in for x, and I got out negative 11. So this whole thing now is gone. I evaluated it. G of f of 4 equals what? Negative 11. So now I have f of what? Negative 11, because this is gone. I just evaluated. I just found g of negative 4, and g of negative 4 is negative 11. So now I put that in. Now I'm going to find f of negative 11. That means I'm going to evaluate f at negative 11. So here's my f function. F of g equals x minus 5. So f of x equals, here's x. I'm going to put negative 11 because I'm evaluating f at negative 11. So negative 11 minus 5. Again, if you struggle with your sign numbers, don't be embarrassed. Just use your calculator. Negative 11 minus 5 is negative 16. So there we go. We did it. Negative 16. H. If you're thinking what I'm thinking, you're probably thinking, boy, how can I get this done in 60 minutes? It's not going to be easy. And that's what kind of separates the 36s and the 34s and the 35s and the 33s from the 25s or 23s or 24s, okay? I mean, it's not easy, and some can work faster than others, okay? But that is how you would solve that problem. So what they're testing here is your understanding of functions and understanding of functional notation. What does this mean over here? F of g of f of g of negative 4. And so hopefully I've explained this, and that helps you understand it a little better. All right, number 29. Okay, this will be interesting, so please pay close attention. For a right triangle ABC shown below, which of the following expressions, which of these expressions right here, has a value that is equal to cosine of A? Now, first of all, let me tell you what they're testing you on, okay? They want you to remember that sine of an angle is opposite over hypotenuse. Cosine of an angle is adjacent over hypotenuse, and tangent of an angle is opposite over adjacent, okay? I'm teaching an online homeschool pre-calculus class for local homeschoolers, and we're doing 3 chapters on trig, and we've been over all kinds of stuff like this. And one way to remember this, I'm sure that Miss Walker and other teachers have showed you this, is SOHCAHTOA. SOHCAHTOA, okay? S-O-H, so, ka, C-A-H, toa, T-O-A. All right, so SOHCAHTOA. And that's what they're testing you on. Do you remember this? And if not, you need to make sure. I'm giving you stuff to study before you take this test, okay? They expect you to know stuff like this, all right? So they're saying this. This is going to be hard. Now, once I show you how to do this, you're going to understand it, but it's not easy to see on your own, so pay attention, okay? Which of the following expressions right here has a value that's equal to cosine of A? Okay, well, cosine of A, here's A, so let's write this down here. Cosine of A equals adjacent, which is 9. This is my hypotenuse right here. Excuse me. So my adjacent is 9. My hypotenuse is 15. Do you see that okay? Cosine of A is 9 over 15, adjacent over hypotenuse. Now, which one of these expressions over here is equivalent to cosine of A? Well, let's just real quick find out. Now, I know because I just have tons of experience with trigonometry, but let's find out. Let's take sine of A and see what we get. Here's A, sine of A, opposite over hypotenuse, 12 over 15. Nope, not it. Let's try the next one, sine of B. Okay, sine of B. Oh, here it is. What's the sine of B? The sine of B is opposite over hypotenuse, 9 over 15. So there we go. So the cosine of A, 9/15, is the same thing as the sine of B, 9/15. So the answer is the sine of B. So they're testing your ability to understand sine, cosine, and tangent, what the ratios are, and then how to apply that, okay? And the last problem for this section looks a little tough, but it's actually pretty easy. When you graph this expression right here, that's called a rational expression. It's graphed below right here. Okay, here's the graph of it. No point on the graph has which of the following x coordinates. Now, I hate how they've worded that, and they've probably worded it that way on purpose just to confuse you and make you think a little deeper, which is fine, but I need to interpret that for you so you understand what that means, okay? No point on the graph has which of the following x coordinates. In other words, what they're saying is which of these numbers right here does not exist on this graph. Which of these numbers here does not exist on this graph? Well, let's see. Let's take a look at -3. -3 exists. It has a point right here. Let's skip -2. Let's go to -1. -1 exists right here. Doesn't that point right there line up with -1? Sure it does. Doesn't that point line up with -3? Sure. So there is an ordered pair. Let me say it to you. Let me express it to you like this. There is an ordered pair on this graph right here, right there, and it's like -1 something. I don't know what the y value is. -1, -1/2, or something like that. But that point, -1, does fall somewhere on the graph. How about 0? Yep, here's 0. Go straight down. Yep. Right there. There's a point that lines up with 0. How about 1? Yeah, there's a point that lines up with 1. I'm going to make another one up. How about 4? Yeah, there's a point that lines up with 4. But look at letter G. How about -2? Is there a point on the graph that lines up with -2? Now, I know it's close. I know it's close. And you might say, oh, I think it does. But what they're testing here is your advanced math ability. Actually, it's algebra 2, but your algebra 2 ability on recognizing vertical and horizontal asymptotes. You see there's an invisible line right here at -2, and I'm not bragging, but I see it right away because I've graphed so many of these in my wonderful, splendid math teaching life. And so there's an invisible line there, and there's also an asymptote here like that, and there's also a horizontal asymptote, by the way, running right through here at about, looks like -1/2. But anyways, my point is this. What they're testing your ability on here is to recognize when you have a rational expression, there's going to be invisible vertical and horizontal lines. Now, some of you have had this, and some of you have not, and that, of course, that I can't help. It's just my job to teach you how to solve the problem. But if nothing else, excuse me, sorry, my voice is starting to go. But if nothing else, you can realize this. You can just look at the graph. I mean, is that not what I did here? I just went through and checked each number, and when you got to, I mean, you say, well, Mr. Earhart, looks like -2 does touch the graph. Okay, fine, but you know for sure -3 does. You know for sure -1 hits the graph. You know for sure that 0 hits the graph. You know for sure that 1, let's see, +1 hits the graph right here. The only one that's possibly not hitting the graph is -2, and so that's the one you'd want to go with. I hope this has helped, guys. I know it's not super easy. We're halfway done, so I hope that you'll continue day after day to watch these videos and hopefully improve your ACT score.